In this video, we're going to continue to talk about topic 2.5 and 2.6. And now we're going to take our basic derivatives and use them to write equations of tangent lines. You will see this pattern over and over and over in calculus. We learn how to take a derivative with a new method, and then we write the equation of a tangent line. So at this point, you're expected to know how to do this, even if we don't do any instruction on it in the lesson. You apply the new method to whatever to the equation of a tangent line. So we're going to start by just taking we need two things to write an equation of a tangent line. Always we need a point and a slope, okay? So it looks like right now we have a point, so we've got that. I need to find the slope. To find the slope, we take the derivative. So I'm going to take the derivative of what we've got. I know that when I bring the 1 in front for the x, and then I subtract 1 off the exponent, which would give me x to the 0 power, which I know that x to the 0 power is just 1, so I'm just going to write the 1. Minus, I'm going to take this 2 and bring it in front, multiply it by -2, I get 4. Subtract 1 off the exponent, I get x to the first, which I really don't need to write the first power. Now, you have to be careful because when you're talking about the slope, there's a little typo there, it should be 8. It's very common to think that the slope is this 4 right here. It is not. You actually need to use this equation to make a calculation for what happens at this specific point, 1, -1. So I'm going to actually need to plug in the value of 1. So I've got 1 minus 4 times 1, which is 1 minus 4, which is -3. So my slope is -3. Now I'm going to use my point slope formula to write my equation of my tangent line. So y minus the y value, which is -1, equals the slope, which is the -3, x minus 1. And this double negative here goes positive. For the AP test, that's where you're going to stop. However, for the homework, depending upon which site it is, you may have to distribute this in and get it into slope-intercept form. So you have to kind of go with what's there. If this doesn't come out as the answer and you've checked it a couple times, try converting it to slope-intercept form. All right, let's do this again. We're going to write the equation of tangent line to the function. They gave us the x value, so we need two things. We need a point and a slope, and we have neither one right now. So I'm going to start with the slope. So begin by rewriting this as 2x to the 1/2 power. I'm going to take the 1/2 and bring it in front. So I'm actually taking the derivative now. So I've got 2 times 1/2 x. I'm going to subtract 1, which is a 2/2, so I get to the -1/2 power. I'm going to clean this up a little bit. The 2's go away. I have 1 in my numerator, and in my denominator I'd have x to the 1/2 power, or 1 over the square root of x. I'm going to continue to get my slope by plugging the 1 in, and I'm going to tell the grader that I'm doing that. So I'm going to say f prime of 1 equals 1 over the square root of 1, which would be 1 over 1, which is 1. Now, I've got the slope. Check that off the list. I actually don't have the point this time. So I'm going to have to go back into my original function here and plug that 1 in to get the point. So f of 1 equals 2 square root of 1. And 2 square root, or 1 square root of 1 is 1, and 2 times 1 is 2. So now I do have my point. So I'm ready to write my equation of my tangent line. So y minus the y value of the point, which is 2, equals my slope, which is 1, times x minus the x value of my point, which is 1. And again, I could simplify it more if I needed to.